So I was yesterday we were looking at the generate master data, sorry, generate time data, which I could not do just because of the reason that in my Eclipse, currently I'm using Eclipse as the um, tool for developing my objects, right? So there is another tool which is HANA Studio. You can use it for doing the developments. So usually if I go here and then quick access, I should get the quick view here. And then I should see a menu, but some of the Java development tools are not working in my Eclipse installation, so it doesn't work. So I have another instance where I can type in quick view, and then you get to this place. So this is a menu, separate menu, what you see here to do several activities for delivery units, transport related activities, and data provisioning in order to access the data from data services and etc. You can use this data provisioning. SLT and data services, we will be seeing this one. And also importing and exporting and mass copy, migrate. If you click on migrate, you will be seeing uh, um, what are the objects you wanted to migrate. See attribute views and analytic views to calculations. So that means these are all not valid in the new versions. You can migrate them to the calculation views. Again, script based calculation views to graphical calculation views and table functions. So you can even migrate your scripted based calculation views also to these functions. And analytical privileges to SQL analytical. These are the three different objects which got deprecated in the earlier releases. So and there are many more with the new migration tool, but we will see them. So generate time data is one option here. So you go in there, and then it is asking calendar type, Gregorian or the fiscal year, and then from year, what year you wanted to generate the time data. So I would say 2014, and then to year 2050 until 2050 I wanted to generate, and then granularity, year, date, month. Yeah, because you wanted to join the date field with your transaction, so you basically go with day. And then first day of the week, either Sunday or Monday, it depends on your thing. And then finish, it is going to generate the data for 2014 and 15. I don't think I'm going to generate the data. Let me see, I have it. Where do you find the data? Go to the catalog. You got a schema called sysbi. Um, in this SBI schema, you have several tables. So my table is yum underscore table time dimension. So if you can see these tables, this is if you select the granularity of year, you will see the data in this table. If the granularity is week, month, or it's going to be the day. So if I go and bring this to my SQL page, I should be able to see the data in there. So this is by date. So I can download this data and upload into my Eclipse version. There is some formatting issue I'm getting, so I don't want to spend more time on for getting the formatting done. For that, I'll do it after, and then by next session I'll be able to get the time data just like this in my custom table. So this is a system table. M underscore time dimension is a system table. I cannot directly manipulate this data table by using insert or update. I'll have to do the generate time data option from the quick menu, quick access menu. Okay, so you can do that same thing for the fiscal data, fiscal year data. Quick access. So generate time data, and you can choose what system and what user ID. So instead of Gregorian, you can choose fiscal year, and it is going to ask fiscal from year to year, and then what schema, and then variant, which is your 1, 2, 3, 4, something like that. Okay. Yeah, that's about the generating the time data into your views, into the system schema, and then you can use them in the views. Okay, so I'm going to come back to my original session. So yeah, let's start more in with the calculation views here. As I said, most of your time you're going to deal with the calculation views in the analytical models. This is going to be one object which is replacing attribute view and an analytical view. Okay, what it looks like, let's create um, one calculation view with the dimension. I go into the same package, and I'm going to create, and I think I created one yesterday, it's for just test, and then I'm going to create new calculation view. General naming convention is just CV. I'm going to name this as business partner, which is customer. So I have several options, standard and time. So it's going to be standard attribute view, and then I have graphical. I got script also, and I'll start with graphical. So since this is going to be a master data, I will choose dimension. So this is disabled, and so if you set the data categories dimension, the default node is going to be the projection. So this is going to be your default node. So you have nodes, several nodes in this place: projection, join, union, rank, and aggregation. Currently, these four are given in the until HANA to SP2 in XSC, XSA. You got intersection, minus, which are also provided in the latest releases. We're going to see them in the later when we go to the XS Advanced. So for now, we will be looking at these four in detail. So projection, I'm going to start with taking a projection into this one. So projection is like your select statement. You're just taking the fields list from your from your table. That's projection means. So when you build your projection internally, it is building a simple select of certain fields or all the fields depending on what you choose. Okay, so I'm going to get the business partner table here. So it is in EPM content, right? It's a bit very slow today. Just bear with me. Oh, this is too slow. I can go to the catalog and to the HANA demo. And then choose the tables. I get the business partner in there. So in my projection, I can only insert one table. I cannot have multiple tables. So it is said select from one table. So if I choose all the fields by selecting on the header and then say add all output, it is like select star. If I choose certain fields, then it is going to be select field 1, field 2, field 3, etc. So I'm going to choose field 1, which is my partner ID. And then as soon as I select it, it is going to be in the output columns on the right side. And then I also wanted to have address, and I wanted to have um, yeah, that's it. I just wanted these two fields from this table, and I wanted to get the address information from a different table. So I need another projection to hold that table. So I got another projection. Yeah, same thing I will do. I wanted address ID to join the address ID in this table, and I got country, region, city, and let me take street also. So I've got several attributes from this table. These are two different select statements. Now I'm going to join them with join node. So I can just drag and then drag the and connect this to the join. So in my join, I'm going to specify what is my join condition is for this one. So I'm going to join based on the address ID to address ID. I just drag it to address ID and then specify my join properties. It's going to be, let's say, inner join and then cardinality, you know it, right? N to 1. And then that's it. Okay. So I wanted partner ID from my projection 1 and then country, region, city from my projection 2. I don't want street. I'm just using here. And then I come back to this place. And then I'm going to join the result of my join to the projection. Now it's not joining, I'm connecting it. So and then I display, I wanted to select all these fields, say add all to output. You get them everything here. And that's it. And the last step is to go to the semantics to identify is there any key. Key is not mandatory in the calculation view, so you can leave that as it is. And then all of them are dimensions because currently my view is of calculation view is of type dimension, so I cannot have measures in there. And view properties, we're going to see each view properties in detail one by one slowly, but for this particular example purpose, just understand data category. See that it is identified as dimension because when we created it, we identify this as going to be as a master data object, so this is going to be a dimension object. Run with definer rights and invoker rights. You know it, when we are working on stored procedures, we discussed about it. If it is definer rights, the person who created it, those authorization will be applied. If it is invoker, the person who is invoking that particular object, his or her authorizations will apply. Hierarchies, yes, we will go and see. In parameters and variables also we will go into detail. So I'm not making any other changes. I'm going to activate it. It's running. You can see completed successfully. So I would be seeing that in my content. I can see it. I can just display the data for this. So it looks like your attribute view. It's very, whatever you are able to do with an attribute view, you are able to do this in this. I'm able to join it, and then country, region, and city. I'm able to get it for every partner, every customer. That's about the basic calculation view of dimension categories, master data view. So you can join multiple tables. So once you join address, you get the result. With this result, you can join another table. With that result, and there could be another table, and so on. So you'll be able to join several tables together in the calculation view of dimension category, but you will always have only the dimensions, and they are not enabled for reporting in multi-dimensional reporting applications like Design Studio and analysis office, but you can see these views in Web Intelligence. Web Intelligence is not a multi-dimensional reporting application, it is a reporting application. So multi-dimensional means you must have some measures which can be analyzed by several dimensions. So in this case I don't have measures, so I cannot see this view in any of the dimensional analysis reporting applications. Okay, clear? I will move on to another example of creating analytical view. So no, not analytical view, calculation view, which is very similar to what analytical view. So I'm going to start the same place, new, jet CV, sales order, and this time I'm going to choose dimension. Sorry. It doesn't change the default view property. I have to go and make it, because if I choose the cube here, it doesn't actually change it. I have to make switch to aggregation. See, I just made a simple mistake. You can actually do, when you are defining, I choose I've chosen dimension, so that the default node is become dimension. But in reality, if I choose cube, it should be the aggregation, which is going to be my default node. Okay, so uh, I'm going to start with a projection. I am going to get a sales order table. This time it is going to be transaction table. So let me take sales order header, and I can take another projection to join status information. I have listed all the views to be joined. Okay, let me, yeah, I think in my example I'm choosing order item table, just because we have seen already header. So we wanted to see item table. So if I don't want this table, I just select that table and deleted it. And then let's bring the sales order item table. And then I'm going to join this with sales order header just to get the status and some other fields. So what I wanted from sales order item, I'm going to get the sales order ID and item, and I'm going to get the note ID, gross amount, net amount, and that's it. Product ID also I'll get it, just in case. And from the sales order header table, I just need the status, which is going to be life cycle status. I don't need any amount to be taken from here. So I take the customer partner ID from this. If I have time data, I can use it, but at this moment I don't have time data. I'm not really concerned about that. So I'm going to join these two. Let just in order to join, I go to the join. It is your join in your select, in your SQL, whatever you do, join. And then what is your join condition? Sales order ID. See, header and ID, item tables, probably sales table, header is very high level document, one document, and item level details, you get each item in that particular document. What is the item, what is the product, what is the quantity for that particular product item, and you may have 10 items in one header document. So header contains the overall purchase, overall sell value of the, the document. Okay, I'm getting the order ID joined here, and then from here I'm getting life cycle status and partner ID. Okay, so every line item of my sales order item table is going to get the life cycle status and partner ID from this one. I'm going to get everything here from this one, and additionally two fields I'm getting with this join. Let me get another join to get the vendor information. See, I already have a calculation view uh, which is built to get the vendor and vendor address together. Sorry, business partner and business partner address together. So instead of making two joins by bringing those two tables, I can use that calculation view in this calculation view. So I pull in a projection. In my projection, instead of keeping my table, I'm going to use the another calculation view which I built just before. So that is my business partner calculation view, and just drag and drop. So it's going to be here. So I get partner ID, country, region, and city from this one. So now I can join this one. So here in my two tables, see, whenever I do my fact table to another thing, it's better to do the left outer chain, just because of the reason that you may not find an entry all the time. So you are going to get something from your right table. So your left table is going to be your fact table, and right table is what you are getting from there. So when you make the left outer join, so you will not lose any data from your left table, but additionally, if there is no data coming from the right table, those things will go, but otherwise you will still have whatever the data what you get here, it will exist, but you may be getting or you may not be getting the values for these fields depending on the common values in between these. So it is better, it is not better, most of the times your requirement is always aligned with going with left or join when you are having a fact table. Okay, and here also I'm going to do the same. I'm going now here in order to connect to this one partner ID. Partner ID I'm going to connect, and then I'm going to choose all these sales order ID, item, gross amount, net amount, product, partner ID I already mapped. I don't need the partner ID, and life cycles. Actually, I don't need the life cycle status. What I wanted is, yeah, let me, okay, life cycle status is okay. I wanted to get the text also, but it's fine. And then country, region, city from this. So I got some more columns. Now finally I can add another dimension view, which is going to be product. So I have a product right here, product in my transaction table. So I can add the product dimension also to it. So let me create one more dimension for the product. It is going to be dimension, finish. So my product is going to have a table. I can even insert product table and text table together and make a join. So, but if I wanted to repeatedly using the product information multiple places, I make a product table first. Product view, calculation view first. So I'm going to put this one into my projection, and then I'm going to get the text for it. So all my texts are going to be here. So I get another projection and then get the product text. So the common field between product and the product and the text is going to be name ID. Yeah. So I'm going to choose product ID and then name ID here, and then I'm going to choose text ID and then language and then text here. So let me join these together. So I'm going to get the product name ID to text ID, and language, you see that, right? This is going to, whenever I have language, I have to make sure I have text join there. And language column, I have to specify language. Okay. And I'm going to choose text from here. And then product ID from this one, and that's it. I don't want more. I'm going to connect to the projection and then select both. And then semantics, I don't need any keys. Let me display the data in it first before I go in further. So I got the product ID and then text for that. Okay. Now I'm going to use this in the sales order calculation view, which is going to be here. Sorry, a projection. Oh, sorry. I should drag the projection first. Yeah, I got the projection, and then I'm going to insert the product here. And I'm going to choose the product ID and text here, and then I'm making a join again. So my left is going to be this one, and then right is going to be this one. So then I'm going to choose order ID. Okay, let me make the join. So I got product ID here, right? I'm going to join the product ID here, and then it's going to be left outer. And I want the text from there. And the rest of fields I can choose 1, 2, 3, 4, 5, 6, 7. I can select all of them and then say add to output. So I'm here. I don't want the product ID to be displayed. I just want the text to be displayed. If I wanted to have product ID, I can have it. There's no, I have it now. But it's really required or not. It depends on your case. Yeah, and then I think I'm good with my view. I'm going to join this with the with the I'm going to make it to the default node aggregation. So I'm in my aggregation. This is the aggregation node I have. So here I'll have to be a little careful. So all my dimensions are going to be normal columns. So this one, add to output, add to output, and item also. But this is going to be a measure. So I'm going to have, I should be doing it as an aggregated column. Okay. And the net amount also add as an aggregated column, and then life cycle status is at output, and the rest of all going to be at output. Okay. I don't know why should I don't see this. Anyway, so now my view is built. I go to the semantics and then just check any yeah, I don't have the semantics for the other. Only aggregated columns are represented as measures. I'm going to say mark as attribute for the, or I have the proposal auto assign, so it does the auto assignment for them, and that's it. I'm going to activate it. So there is a calculation view is built just by joining one with other and to the top. Is right. So let me see the data in there. Sales order data. So I got my measures here, and then I can bring any dimensions to it. So this is the gross amount by country, and I can take it out and by region. I can do it by sales order ID, which is going to be all the records, document level, and by item. That's the most detailed level. Okay, so that's about creating the calculation view, which is cube type category. I can also do the same exercise using a star join. Let's create another one. Okay. See, time CV is like time dimension in BW scenario. Similarly, in BODS, you got time data. So what it brings a lot of other columns, not only your data, your just date, your date column. It provides complete granularity of year, quarter, and etc. See, in your BW, when you're working, if you map your calendar day to from you can map your calendar day to a calendar year, calendar month, quarter. It automatically derives it. How does it derive? There is a standard functionality inside built to get all the time characteristics derived. Similarly, if you want that to happen, to get the calendar year, calendar month, calendar quarter, and the hierarchies, proper hierarchies from the year to quarter to month to date, you need the time dimension for, it's a standard dimension. Even in BW or BODS, you have a standard dimension for time. You don't create your time dimension, you will use the existing time dimension just because you will have all the standard functionalities associated with the hierarchies, auto time conversions, auto time mapping, and etc. You can still achieve with your own time dependent time creation table, but you will miss some of the functionalities which are part of the standard system. So that's the time dimension. If you're when you're working in ECC, if you're working on ECC tables, you got several tables for fiscal year period and etc. Right? I think I don't remember on top of my head some of the tables which are starting with T for the fiscal year configurations and etc. You will have to deal with those. In order to deal with those tables, you need to have the time dependent data properly configured with the generate time data option according to the fiscal year period and etc. Especially fiscal year, you will have a lot of importance in the in your analytics. And what's the other one? Yeah, one projection you can only keep one table. You cannot keep two tables in one projection. So if I have to get the other table, I need another projection. There is no projection can only take one table as input. The execution of the calculation engine I'm going to show you tomorrow. That's when we debug the calculation engine, it is going to show how the instantiation process is going to happen. How the each field is going to be selected when I run the see, you can see just in a minute, debug this view. If you select debug this view option here, you may have to do this one when you're working in project to understand what is happening in each node. Generally, people just go to the each node and say display. I would say it's better to do the debug this view option. Let me take the simple one, business partner. So as soon as I click on the debug this view, I'm going to get the select statement. So I can execute this. Yeah. So it's going to generate an SQL, and then you can see that in every projection here, this is my first projection, projection 1. So there is an SQL generated for this. So what it is selecting, partner ID, address ID. Did I select address ID in my report? I don't think I selected address ID. I don't need the address ID in my report. When I choose and debug, you saw that, right? When I display the business partner data, you can see here. I don't have address ID anywhere requested, but still it is bringing here. You can see that, right? I can execute that. So it is bringing partner ID and address ID together. And from the next projection, it is forming a select statement like this. It is bringing country, region, city, address ID. Here also I don't need address ID as an output column, but still bringing. Why it is bringing? Because on the top level join node, I need the address ID to join these two tables. So for that particular reason, it is making the select statement accordingly. So column engine or calculation engine is very smart to understand what columns to be read in this SQL preparation and what not required accordingly. And then accordingly it comes to this place, and this is going to run here. And at this level, it requires partner ID, country, region, and city. And then my final projection, it requires only partner ID, country, region, city. It skips the address column because I did not request, our business user did not request it. So you're going to get this one. That's going to be your final output. So this is the instantiation process. We'll have to see it in the detail how it is going to work, the instantiation process. Okay, it is, don't see it. Should have a document. I am missing here somewhere. Yeah, there is I have a document for the inserted in the, calculation engine process. We will look at that in detail. Yeah, just to end this session, the same thing what I built here, I can do the sales order view. Whatever I built here, I can do using star join. So how do I do it? Let's see. Go to new JCV. What is that? Sorry. Yeah, sales order star join and cube, and then I have little checkbox here. I'm choosing that. So I got a default node as star join, and what is my base table is going to be sales order items, right? That's what I initially started with. So I'm going to get a projection, and then I'm going to start bringing my item table here. Sales order okay. I need item and gross amount, net amount. Come on, slow. Okay, product ID, and I got gross amount, net amount, and that's pretty much fine for me. And then I can also Either do it for header status, I can get the header table. If I don't want a header table, I can just skip it. So I'm taking this table to my star join. Actually, I can insert this table directly here instead of this. Sorry, I have to do, since I put it in here, I can join it. Oops. It's not very well today. System is slow. Okay. And I'm going to put it in all the other calculation views into this. So I got business partner, I got product, I got, yeah, whatever, how many, whatever you got, you can put it in there. So far, I have only just two. And then let me map them. Sales order ID is my, and then I'm going to have product ID to, come on, product ID to product ID, and sales, missing something. I need partner ID. So in order to get my partner ID, I need the header table, right? So I need to get the header table before this join happens. So for that, I need to go back to this projection and then remove this projection. I can just delete it. I can insert another projection and drop the sales order. I mean, drag and drop the sales order header and get my partner information from this one, and that's it. And when I'm joining, join, I'm going to join with order ID, sorry, partner ID, sorry, sales order ID to order ID, and I want partner ID from there. I got sales order item, gross amount, net amount, and product ID. So that's fine. Now I'm going to give this to my analytical join. So I can now join these two tables. One is sales order product ID to product ID, and then I can join partner ID to partner ID. Yeah, if I have some more, like you got see here, right? Employees, you can say you can join to employees, you can join, these are the different master data tables. You can join to some other text tables. Yeah, whatever time dependent tables or whatever you can join together. So when the central table, your fact table is there, it is going to be always the left operand, this one, and it is going to be left table always. Your table is going to be left table. You cannot modify that. Join always happens from this to the other tables. So you can say left outer to get the dimension value. Similarly, left outer to get the dimension values. If you don't get the dimension values, it's going to display null value. So I'm going to select whatever I wanted to have. Sales order ID. I wanted the item, gross amount, net amount. Product ID, I'm taking it from this table, right? So I don't need to duplicate this, which is fine, and then I go to the star semantics. All my dimensions, shared dimensions are here as dimensions, and then all my I need to assign for sales order header and see these ones gross amount and net amount are automatically aggregated columns, and that's it. So even I mean I can build an attribute view, sorry, another calculation view for header table, right? Header what I'm getting is only the product information. For that I don't need another projection here. I can do another calculation view and add that calculation view into the StarGen. I can do that since just because I don't have time, I didn't do that. You understand what I was trying to say? I can build the logic of getting the header information directly in the StarGen itself. So my item table is going to be the center table for StarGen, and header status is one side, and I'm going to get partner information from one side and product information from one side, time is from other side. It's an analytical join, it's star schema I'm making it. And then it's activated and it's going to display the same results of what you have got previously, join after join after join after join. But I can do all joins together in one star join. And as always, star join is the best optimized way to do the joins. Uh, we have some theory for that. There is no, yeah, there are some statistics we have taken. So when I do the star join, all the joins parallelly go and make it working. So your performance is going to be improved a lot. If you do the other one, join by join by join, you will end up in 10 different joins, and then each join is going to consume certain amount of time, and it is not good for performance perspective. So if you are able to do the star join, better you do the star join for your requirement, especially when working in ETL data warehousing analytical model. Okay. Yeah, so tomorrow we'll start with more about instantiation process, how the calculation engine works, from what level it starts in detail, what exactly it goes and picks from this table, and how does the select statement, I've shown already, but I will show you in detail with an example. What if user requested a different column, then automatically calculation engine is going to change according to the user request. So that's how it is optimized in a effective way. But SQL engine is different. But all this is going to be executed in calculation engine most of the time. Okay. It is automatically aggregated in StarJoin. Let's see. So this one, I don't, this one, right? You're asking add as an aggregated column or add as a add to output, right? So there is no such thing because you're an analytical join. This is an analytical join, fact join. So when you are in star join, this is only for OLAP related activities. So the one previously you did is not OLAP thing. So you have to specify what is to be aggregated, like your select statement. When you're saying group by, you will have to say select sum of gross amount. So in order to say select sum of, that's what you're saying, add as an aggregated column. For the analytical join, it is automatically taken as add as an aggregated column. So you don't need to do that. That's what you cannot see that in, come on, it's slow, but you cannot see, it is automatic. As soon as you select, it automatically becomes as an aggregated column. Okay. Yeah, I think the server is little slow today, but I hope, well, yeah, there are a lot of things to um, cover. we have seen this example 3 also. Create a calculation view with cube category plus star join with the same example what we have done for example with all the joins one by one. And then in the next topic, yeah, we will see the properties in detail. So the properties means the in the semantics we got several properties, right? So we're going to see those properties and see the detail options what we have it. And then we will move on to union node, rank node, and aggregation node in detail. The aggregation node, rank node, and union. These three nodes in detail. Yeah, basically you would have seen these ones already in SQL. When we were learning SQL, you would have seen aggregation. Aggregation is when you do the select sum of and then group by class. That is your aggregation. What you see here. Not in this. So behind, if you see the select statement for this node, it is going to generate the SQL which we already learned there in initial sessions. Union node, there is a statement for union all. We did not see it. Just like on join, you have union statement also to combine the data in SQL. For ranking, we have seen the window functions, row number, rank function. They are graphically given in rank node. Yeah, so most of the things what you see here, if you understand from SQL coding perspective, it makes more sense to you and you can understand very well. So always try to understand from SQL perspective, and because the dragging and dropping, uh, one thing, very important thing what I learned in the last few years is people start with the graphical modeling and then they just drag and drop in objects into the projections, joins, and actually they don't know how exactly internally the select statements are formulated in the background. So they just play around with selecting the fields, projecting them and showing it in the reporting, and they will learn from. They actually, it's not the proper way to do it, because you may find it easy to do all these joins, but when you got a big requirement, it is not possible to do the joins. SQL is the easiest way to do the complex logics to be defined, but people feel that it is the easiest way. In reality, it is not. It is for demo and training purpose, and like just like what I am explaining to you, it is looks very easy. When you really go into the complex logics, SQL is much better in terms of coding your requirement, because you've got a lot of control in doing all different keywords and cursors looping and etc. But you wouldn't be able to do that in your graphical editor. And even the complex joins what SAP has given as part of HANA Live for controlling finance in SAP ECC, they were able to do the models in graphical calculation view way, because they know how the SQL engine works, how it works. So that is the reason the architects of SAP product development, they can do the calculation views very easily, because they know the functionality of each node, because they developed it. But for the people who use those objects, it is not very good object for a complex requirement, for complex. And if you learn SQL very well, you can do these things also easily. It becomes more easy for you, even the graphical ones. But SQL way is always the better one. Okay. So the first 7 sessions, what I've taken is not some just because of the curriculum I took it for purpose. So try to do more SQL and then try to correlate with SQL with each node. Then you will get good understanding. Building calculation view is simple. In 1 hour you can drag and drop everything in. But what is more important is many projects suffer with poor development skills, people just build calculation views and give it to the reporting, and then they start feeling problems about performance. They see huge performance issues. They see wrong results. This, yeah, all this is because of the poor development of the calculation views without understanding proper SQL generated behind the scenes, optimized SQLs. Only coding background SQL developers can do effective graphical modeling, not just dragging and dropping certain objects into these nodes and playing around. That doesn't work. But first 7 sessions of SQL, and then and try to correlate those topics into these views will help you to develop a better design for your reporting and analytics. At the end of the day, when you give this model to reporting team, they should not have any complaint of performance and results. So that should be the objective, not the graphical joins together and making it ready for on a nicer way. Okay, I'm stopping here. I will see you tomorrow.